Hey, and welcome back to class 9 of Python scripting in Cinema 4D, c4d208. This week is the third week in our plugin series, and as promised, this week we're going to look at two different plugins, a tool data plugin and an object data plugin. And since we covered most of the tedious basics in the last weeks already, I think this week you will see that it's really much fun to create your own plugins and that it's really easy to extend Cinema with your own custom objects and custom functions using the tool and object data plugins. All right, let's get started. This next plugin is going to be an object plugin. This is kind of easier to set up than the command plugin before because we are not going to create our dialogues through the source code, but instead we're using the description files. First, let's have a look at the register function. Where is it? There it is. The register object plugin function is very similar to the other ones, only the order is slightly different. So once again, we're passing an ID, a name, the function, the class rather, that the object is supposed to be of, a description, and this description is actually not a string, but well, it is a string, but it's not a name or something, but it's the file name of the description file that's going to be containing the description of the GUI for this object. Then the usual flags you can enter, and these are a bit more important than in the case of the command plugin, because here you can decide what kind of object you're generating, or what kind of object your plugin is going to be like. And if you remember the Python generator from a few classes before, that is an object of type object generator. And if you wanted to do something like that, you would have to pass this flag into the function here, as well as the object polygon object. And that's actually what we're going to do now. So let's have a look at that source. And that's open here already. And I've just called this plugin object.pyp. And the initial part is exactly the same as before. And then we're calling the register object plugin. And we're passing the ID, the name, and here's the name of the class that's going to be creating the plugin. And then there's just the name of the description file and the flags and the icon. And you notice the difference here. I didn't just put in the parameters separated by commas, but I also put the name of the parameter in here. I find that in cases like these with methods with so many parameters, to be a bit more convenient because I can see which is which much more easily. And also, if you use this kind of description and this kind of way to pass in the parameters, you can actually change the order in which you pass them in. Otherwise, without these names, you have to use exactly the same order as the method declaration demands. Another special feature here that you should know is this kind of pipe symbol here. That's the way to connect more than one flag. So if you want to pass several ones, you just take one, put a pipe in, the next, another one, and so on. And then of course we have the description file here. Now that's being hosted in the resource folder, just like the icon. So let's have a quick look there. So this is our object plugin now. And in there we have the source code, of course, and the resource folder. And in the resource folder, there's quite a bit more going on than in the previous plugin. So the icon is the same as before, but then we have this c4d symbols.h, which is a header file. And we have two subfolders, description and strings. Description is where we find another resource file and another header file. And you notice already the names of these files are the same as the description here. with only the extension being different. And this is important because if this and these don't match, then Cinema can't find them and you will get an error message. So it's only the extension that's different. And in the strings, first of all, you see here it's strings underscore US. That's the language code. So if you were to make a multi-language plugin and you want to have several languages in there, you would have to do a strings underscore US for the English one, and like a strings underscore DE for the German one. If you only have a single language in there, you see strings underscore US because that's always the default one. In there we have a c4d strings.str and another description folder. And in there we have again that same name with an str extension. Now let's have a look at all these files. So I have them all open up here already. So here's this one. Here's this one. And these two are here. So these are all those files. Let's start with that one first, and this one here, because these, they are basically empty. There are just a few comments in there and an empty enumeration here and an empty string table here. These only have to be in there because Cinema expects them to be at this location. So you have to put them in there, but you can leave them empty, just copy and paste them, or just copy the entire file as is. And this is actually the same again on Windows and on OS 10. So these files look the same in both cases. And we can actually close them right away because we do not use them. The more important ones are these three. Now, let's start with the RES file, which is the resource file which defines your dialog. The resource files always start with the same first line, which is container, and then the name of this file, or rather the name of that object. And again, it has to be exactly the same as in here. Then you open a bracket, and within there you have the definition of the dialog, which again starts with a name, and these have to match. And only notice that this one ends with a semicolon and this one doesn't. And then you include a certain base type, and in the case of the object plugin, it's the O base. For other plugins, you have to include a different one. Like for the like for a tag, it would be T base instead of O base. Next up, we have the first group, and the group once again is type specific. So it starts with ID underscore. That's the same always, but then you get object properties, and if it were a tag plugin, it would be tag properties. And the difference being that when you look at the dialog that we get here, that's the object properties one. So for this ID underscore something properties, you get a tab here with your GUI underneath. So that's our object properties. And within, I have defined two links. And this is mostly to show you how much easier it is to do it in the description file than it is in the source code. So all you do is just type in the type, which is link, give it a name, and you can pass some optional parameters in here or leave it be. If you just have an empty bracket, then you just get the default settings. I have created a second one, and in there you can tell the link to only accept certain types of objects. And in this case, I'm telling it to only accept cubes, and let's see if it's actually working. So we have here our all objects, and there's a sphere, and that works fine in here. And let's drag it into the, and you see here it's not being accepted by the cube. And let's double check, create a cube, and that works. So this way you can limit your link fields to only accept a certain type of object. And you see it's really easy. So all you need to know is the base type. Right, and then we have subgroups. And just like in the source code, we can tell it to have a specific number of columns. So this is just using the keyword columns followed by the number and a semicolon. And well, we have a bool, which is the bools appear as checkboxes, and longs appear, well, just as that, as a field for an integer number. So then we have here a real value, and we have slider settings, and I'm just noticing if we look at the result here, radius, that's just showing up as a regular real value here, but no slider. So I've actually missed something in here, and that's this setting, and I forgot to put that in. So we have the custom GUI once again, and this is the real slider custom GUI for a real field. Let's save that and do a reload. And you notice nothing has changed, and that's because we're using a description file. Like I told you a moment ago, when you use a description and you reload the object, the source code is being refreshed. So if I had changed the plugin itself, that would have worked, but the GUI doesn't work. So I have to actually close, and no, we don't want to save, and start it again. Whoops, that's a bit big. Okay. And now we have the slider in here. So, just like before, you can't out of the box tell it a real field to be a real slider field. You have to pass in the parameter custom GUI and tell it to be a real slider. Now we also have a native vector field, and we can pass in parameters for each field here. And we have more groups. So while these groups were just grouping parameters together, these groups have a name. And when they have a name, then you can get a named group like these, and then you can fold them together. And within you can have further UI elements. And what we have here is also a file name dialog, for example. And well, that's quite handy. And let's see how that's defined. Very simple. Also just file name and the name and the color dialog. And we were all putting these within the object properties. And when we create another group, again, a named one outside of the ID underscore one, then you get a, well, like it says here, another tab like this. And you can have your separate properties in there. So that's really simple to set up. Unfortunately, that's not all you need to do. You have to also fill out these other three files. Let's look at the header file first. And you see here, it's similar to what I defined as global variables in the last plugin. It's an enumeration file, and by default this should already be in there. And notice first of all this part here, and that's exactly the same name again as the other ones. You have to put that in, and then you have to make sure that for each entry that you have here, like for each of these variable names, you have to have one entry in here with a unique ID. Once again, you should start at 10,000 and going upwards. And you have to make sure that you really do this for every single one, including the group names. So all of these need to show up in here, and also in the string table. So for each of them, you have to give them a name. If you don't give them a name, some of them will work without a name, or some of them, like the tab, will just not show up as or the folding group will just not show up as a folding group. But some require a name, and they will throw an error if this is missing. So I suggest to just take the entire list here, copy and paste it over, and then fill out a string, whatever it is, for each single one. And when all 3 files are filled out and all the other files are present in the resource folder, then this will read this file and then generate an instance of this object type, which is inheriting from plugin's object data. And once again, we have an init method. And in here, we have an interesting function called setOptimizedCache. And if this is set to true, then your object is being generated once. And if the object doesn't change, then it's not being regenerated on every frame, which of course is it's using up much less performance than if you were to generate it on every frame. But unfortunately, it also can mean that not that you have to make sure that the cache is being refreshed constantly, or when something changes underneath. So for our trial purposes, I've set it to false. So there's no caching. So on every frame we regenerate the geometry. But in practice, you should probably have this set to true and make sure that only when there's a change that this cache is being refreshed. This is but only the initialization. Nothing much happens here. The real meat of this object data happens in get virtual objects, at least in the generator objects. So whenever this plugin is being checked out, it's being checked for the get virtual object, and it expects an object as a return value. And this works exactly like in the generator object in the Python generator. So and I'm basically doing a low-cut version of what we did in class 2 with the randomized polygons. So I'm just getting the object that's within this plugin, or underneath rather, and turning it into a polygon object and randomizing the polygons. So this should work now if I create a sphere, for example, and drag it underneath. There we go. We have some random geometry, and on every frame, because it's being regenerated, and I'm using the frame number as a seed for the random number, we get a different one on every frame. So there you go. That's your object plugin, and that's the example for a number of different UI elements using a description file. Finally, we're going to look at a third example, which is a tool data plugin. The tool data plugin is being registered pretty similar to all the others before. So once again, ID, a name, some flags, and an icon, and the rest you can more or less ignore. And then there's, of course, the object that's going to be created for the plugin. So let's have a quick look at why these tool plugins are so cool. It's because, whoops, no, wrong one. Because they offer a number of functions to catch user input. And especially the mouse input, of course, is very cool because you can then draw on the surface and generate objects this way, which is basically what we are going to do now. So let's have a quick look at the plugin itself. So once again, it's having this very descriptive name called tool. And there we have our source code. And once again, I'm going for the simple version, which is just using the icon in here and is generating the UI from within the source code. So here's our register function. This is once again exactly the same. So basically this part here, I only ever copy and paste from one to the next, because it works for every single one. The register tool plugin expects the ID, and it gets it, the name, and these were the flags, and I don't want to set any special flags. And that's the icon. And in the end, I am, actually I don't need those brackets here. I'm calling the function, rather the class, which is this one here. And there's our tool data class, inheriting from plugins tool data. Sorry. So that's quite straightforward at this point. And then the tool data has like you saw in the documentation, it has the mouse input, and that's what we are using as well. So these init functions we are basically ignoring because we don't need to init anything. And this one is actually quite interesting as well. So this one is catching the mouse input, but the moment that you open your plugin, this will be called automatically, and it's opening a sub dialog. So where before we in the command plugin we manually opened the dialog for us, this is being handled by Cinema for us in this case, and it looks like this. Let me just restart Cinema because I swapped out the plugins, but I didn't restart. There we go, there's the tool. And when we call the tool, first of all, we see our icon here. And then the sub dialog is being called automatically, and this is the sub dialog. It's being opened in here in the attributes. So that's being handled by this, and this is calling our dialog. And the dialog is inheriting from the sub dialog class. And the subdialog class is actually a child of the GE dialog class. So if you look at this, let's see, the GUI, there's the subdialog, and the subdialog itself has no methods of itself. It's just a well, it's a child, but it's entirely inheriting only from GE dialog. So anything you can do in GE dialog, you can do in the subdialog. And that's why the G dialog has the create layout function just like the GE dialog. And that's where we create our very simple interface. And the init value is just called init dialog. And the init dialog is empty, so there's really not much in here. And it's not doing much. So this is just an interface to collect some parameters for us, which I will then use in the main function. And I'm using a little trick here because when I'm calling the subdialog, I'm making sure that when the subdialog is being created, the return value is written into a dialog value, which is a class value. So that makes sure that I can, from within the mouse input one, for example, I can still access the dialog and get its parameters here. Where is it here, for example? If I didn't do that, then from these functions here, I would have no access to these dialogues, and obviously I wouldn't be able to get to any of these settings. But I do, so that's all good. Right, so the mouse input gives us a number of parameters automatically straight from Cinema. So there's the doc, which is the current document. There's data which holds the. I'm actually not sure what kind of data it holds. We don't use it in any case. The BD is the base draw, which is the surface where you're. Well, this basically here. That's where our mouse is drawing on. The win is the window, and the message is containing things. It's a base container containing all kinds of information, like, for example, the mouse location. And that's where we are catching it. So the message contains, you can see here, it contains, for example, which mouse button has been used. So if the right mouse button was used, then we just return true. We don't do anything. Otherwise, we continue. And like here, we can grab the BFM input X. That means that's where the X and Y coordinates of our mouse. And if you actually want to know what kind of values are available, then let's go back to that. Tool data, there we go, mouse input. And where has it gone? Well, once again, it's quicker to use the C++ documentation for this. And if we search for BFM input X here, then we see we get all these values in the BFM input CIDs, and all this data is going to be in the message. So whatever you want to know about the mouse, you can find from there, and then you can just grab these values from that message. For us, it's enough to know the location where we clicked, and then I just set up some random values, and we start the undo again. I'm creating a new circle object, and I'm setting the radius of that circle to a random size, dependent on whatever we set up in the UI. I'm setting the rotation as well to a random value, and remember this expects radians and not degrees, so I'm using pi, which is much better for radians, obviously. And I'm also setting the position, and here's a nice function that is very useful if you're working with the mouse. It's slightly hidden because it's just SW, but what it does is it translates the screen coordinates. So the screen coordinates being just like the pixels X and Y where you click, and it translates them into world coordinates. So in our case, when I'm clicking on X and Y, and that I have defined as 500 as a fixed one, otherwise it's always 0, it will translate it into the proper position within 3D space. Because if I'm not doing this, then let's say I'm clicking here and whatever comes out is something like, let's say 500 and 800 on X and Y, then that's going to set X and Y as 500 and 800 in world space, which can be anywhere depending on where my camera is pointing. Whereas if I'm using the SW translation from screen space to world space, let's see, when I'm clicking here, it's generating the circles where I want them. See here, I can now just click around in 3D space and position them wherever I want, and it's translating them correctly in 3D space. Perfect. And with that, the function is also finished. So, and you just saw it's working fine. So that's a tool plugin for you. And here's another function that I have commented out, and that would grab keyboard input instead of mouse input. And you can, of course, combine those. So you can catch mouse and keyboard input at the same time. So this concludes my examples of plugins for Cinema 4D, and I hope it gave you a good idea of what you can do with the various types of plugins in Python. And unfortunately, the time was not enough to have a look at all the types of plugins there are, so there are still a number of them left that we haven't had time to look at, like the tag one. But I think the object command and tool data ones are the major ones. And the other ones you will probably figure out yourself, or just post in the forums if you have problems, and maybe we can work it out there. In the meantime, let me know if you have any trouble, and please make sure if you have created any plugins of your own to post them in the forums as well, so we can all have a look at them and maybe improve them, or maybe just enjoy them. So yeah, hope to see you next week for the final class, and until then, see ya.